Hello students, my name is Sumit Mehta. So in today's lecture, we will discuss about a plane. So students, a plane is determined uniquely if any one of the following is known. Means out of this, we need one quantity to determine a plane uniquely. Okay, so the first thing is the normal to the plane and distance from origin. That is equation of a plane in normal form. It passes through a point and is perpendicular to a is passes through a point and is perpendicular to a given direction. Okay, so the third point is it passes through three given non-collinear point is passes through three non-collinear points okay, so out of these if any one of it is given, we can find out the plane. So first student, we will discuss about equation of plane in normal form. Okay, so let me draw a plane. Let's say this is your y, this is your x axis, and this is your z axis. Okay, so let's say this is a plane line here. Okay, so to determine a plane, we need the distance from the origin and the perpendicular vector, as I have clearly stated in equation or the point 1, the normal to the plane and distance from the origin. Okay, if ON is a normal from the origin to the plane, let's say this is a normal, N is normal to the plane and N is the unit vector, normal unit vector. So I can write ON as, this is point N, ON as dn, where d is the distance from the origin and n is the unit vector. Okay, and let r be a position vector of the point, any point on the, so this is any point, r be a position vector. So the equation of the plane will be given by r dot n is equals to d. So this is the equation of the plane in normal form. Okay, so this is vector form, student. To write it down in Cartesian, let us say OP is given by is equals to r vector, and this is xi plus yj plus zk cap, and n vector means the n unit perpendicular vector li cap plus mj cap plus nk cap. So I can write the equation of the plane in Cartesian is Lx plus My plus Nz is equals to d, where L, M and N are the direction cosines of the perpendicular vector and X, Y, Z and are the respective coordinates or the respective direction ratios of the OP vector or the radius vector. Okay. Now let's discuss the equation of a plane perpendicular to a given vector and passes through a given point, the second form. So students, now we are discussing about this second form means the equation of a plane when it is passes through a point and is perpendicular to a given vector or given direction. Okay, so let's say, let me draw, this is xyz. Okay, let's say this is a plane given. So what we need is the point, any point A on the plane. So this is OA, and the second thing is the distance from the equation of a plane perpendicular to a given vector. So any perpendicular vector is given, n vector, which is perpendicular to the plane. Okay, so the equation of this plane will be like r minus a vector dot n vector should be equals to 0. So r vector minus a vector dot n vector is 0. And to write this is vector form, and in the Cartesian this will become where you can write down r as xi plus yj plus zk, and a as a vector as x1i plus y1j plus z1k, and where n vector perpendicular vector as ai plus bj plus ck. So I can write this as a times x minus x1 plus b times x minus x2 plus c times x minus, this is y minus y1, sorry, and this is z minus z1 is equals to 0. So this is the equation of the plane when it is passing through a point and is perpendicular to a given direction. And in the last, we'll discuss about equation of the plane passing through three non-collinear points. So students, now we will discuss third, when the plane is passing through three non-collinear points. So let me draw this. So let us say this is a plane, any plane given, and there are 3 points P, R and S. So this is OP, OR and OS is given. Okay. So let us say in these 3 points R and S and T be 3 non-collinear points with position vector A vector, B vector and C vector. Okay. This is another point T. So this is A vector, B vector and C vector. So I can write the equation of the line as R minus A dot B cross C, or you can say B minus A vector cross C minus A vector. So this is the vector equation of the line plane passing through 3 non-collinear points. Okay students, now we'll study about coplanarity of 2 planes and angle between 2 planes. Okay, we'll discuss that in next lecture students, so stay tuned for that lecture. Thank you, happy learning.